Hello everyone. In this video, I'm going to go over some questions about making probability distribution tables and calculating expected value. So in the first question, it's about blackjack. When playing blackjack using the standard deck of cards, each card with a number has a point value equal to its number. Jacks, queens, and kings have a point value of 10, and aces have a point value of 11, assuming that we're playing with aces high. You can also count aces as twos, but just for the purpose of this problem, we'll do, wait, are they twos or ones? I forgot, it's been a while since I played, but we'll assume that they're 11 for this problem. Suppose you draw one card at random from the deck, make a probability distribution in the form of a table for the possible point values from drawing one card, and then we're going to use the table to calculate the expected value of the point value of drawing one card. Okay, so we need to make a table. And I'm just going to go ahead and start it with I'll just start it with kind of a random number of rows here, and then we'll put more if we need them. Okay, so on the left here, we're going to put point values, and then we're going to put the different values that we can get from drawing cards. So for number cards, the smallest one is 2, and then they go up like this, and now I need some more column, or I need some more rows. Let's see. All right, I can have up to 9 for the highest number on a card, and then the face cards have 10, and the aces are 11. So I'll delete my extra rows here. I'm going to go ahead and put total right here because I want to use this last column here to do the expected value, and I'm going to add it up at the end. I'll put probability here, and then for expected value, we're going to do point values times probability, and then we'll add those up. Okay, so what is the probability of drawing a card that is worth 2? So there are, the points go along with the rank, and there are 13 different ranks. So I'm going to do all of these out of 13, like that. Okay. You could do this out of 52 as well, and then you'd have a bunch that were like 4 over 52, which actually is 1 over 13. So the probability of drawing a 2 card is one of the 13 ranks. So this is going to be 1 out of 13, which is the same as 4 out of 52. Probability of drawing a 3 card is also 1 out of 13. So for all the ones where it's that card's rank, these are all 1. And I will give you guys a picture of the deck of cards in case this part is concerning to you. Jacks, queens, and kings. So there are 3 different ranks that give us a point value of 10. So that is going to be 3 out of 13. Or it would be 12 out of 52 if you use the whole deck as the denominator. And then 11 is only for aces, so that's 1 rank. Okay, so if we add these all up, it should come to 1. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. And then plus 3 is 11, and then, wait a minute, did I miss something here? Oh, right, I forgot that 10s are actually also a number. Right, 9 is not the highest number. We have 10s as a card. So this should actually be 4. So both 10s and jacks, queens, and kings all have 10 points. Okay, good thing I added that up to see if it equaled 1 or not. All right, now I'm going to multiply my point values times the probability. Make sure you understand when you're multiplying a number times a fraction, you multiply that number into the numerator. The denominator is still there, it just stays what it is, and this 2 is multiplied into the numerator. Okay, so I'm going to have a numerator here of 2 times 1, which is 2, and then that is still going to be over 13. Okay, here it's going to be 3 times 1 over 13, 4 times 1 over 13. Well, goodness, these are all turning out to be, I'm multiplying them all by 1, right? So these are very predictably just the number over 13. Okay, this one, the next one here should be different. So 10 times 4 is going to be 40. All right, and then this one is 11 over 13. Okay, so now I'm going to add these up, and it's important that I actually don't simplify because I want them to all have the same denominator. Otherwise, I would have to do a common denominator. Okay, so I'm going to add up all these numerators, and then that is going to be over 13. Don't forget you still have the denominator. It's just not part of the addition. So we're doing 2 plus 3 plus 4 plus... Okay, so I got 95 on my calculator, and then that is over 13. I don't think that simplifies, but I don't really care if it does. For my purposes, you don't need to simplify things like that. Okay, so that is it for that one. And let's look at the next one. So an archer shoots arrows into the target at right. So this is a square target here. Assume that the archer always hits somewhere on the target and the likelihood of every point on the target is the same. The outer blue region is worth 1 point, the middle gray region is worth 5 points, and the inner orange region is worth 10 points. Make a probability distribution in the form of a table for the number of points the archer can get for shooting one arrow, and then use the table to calculate the expected value of the points from one arrow. Okay, so we're going to do another table. Okay, so I just went ahead and put this in while the video was paused. So we have point values. There's only 3 different point values. There is 1, 5, and 10. And it says that he always hits, or he or she always hits somewhere on the target. So we don't need to put 0 or anything. And then we're going to have probabilities. So every point is equally likely. That means every square here is equally likely. And this is a 5 by 5 grid. So there's 25 total squares in the grid. How many of them are worth 1 point? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think. So this will be 16 out of 25 for the blue region. And then the gray, that should be 8 squares out of 25. And then the orange is 1 out of 25. Okay, so then we're going to multiply these numbers together for our third column here, and then add them up for the expected value. So 1 times 16 over 25, 5 times 8, what's that, 40 over 25, 10 times 1 is 10, 25, and now I'm going to add these up. They're all over 25, so I can just add the numerators. So 10 and 40 is 50, plus 16, 66 over 25. And that's it. The next one, consider the deck of cards shown below. Each card has a point value equal to the number of shapes on the card, 1, 2, or 3. Okay, so I guess like this is a 2-point card, and this is a 3-point card. Make a probability distribution in the form of a table for the number of points you can get from drawing one card at random. And then we'll use the table to calculate the expected value. Okay, so here's my table. The number of possible point values, it's the number of shapes on the card, so you can only get 1, 2, or 3. The probability, how many cards do we have? So we're assuming equally likely to get each card, I guess. 1, 2, 3, 5, 5. This is 15 cards. Okay, so how many of the cards are 1 point? Oh, actually, it's just these rows. So like 1/3 of them have 1 point, 1/3 have 2 points, and 1/3 have 3 points. This is going to be 1/3, 1/3, 1/3. Or you could do it as 5 out of 15. I'm just going to do it as 1/3. Okay. And now I'm multiplying these together. So this is 1 times 1 over 3, 2 times 1 over 3, 3 times 1 over 3. And I'm still going to leave this one as over 3, just so that I can add it to the other ones. So 1/3 plus 2/3 plus 3/3. 1 plus 2 plus 3 is 6. Divide by 3. Maybe I'll go ahead and convert that to 2, since I think it's pretty easy. All right. So expected value of 2 should make sense in this context because there was an equal number that were the same distance above and below 2. Right, so like whenever you have this kind of equally distributed numbers like that, you'll land right in the middle for the average of them. Okay. The last one in this section, a bag contains 20 pennies, 10 nickels, 10 dimes, and 5 quarters. Did we do away with pennies, you guys? I'm so behind on keeping up with things that I don't know whether we have still pennies or not. Okay, a bag contains 20 pennies, 10 nickels, 10 dimes, and 5 quarters. Make a probability distribution in the form of a table for the amount of money you can get from drawing one coin at random. Then use the table to calculate the expected value of drawing one coin. I mean, I should maybe defend myself by saying, like, I do know what's going on in the important news. I just don't know about pennies, and they don't seem important, so I'm not going to Google it. All right, let's make a table. I guess I'll find out the next time I try to pay for something with a penny. Okay, so here is a table. I just copied this from the last example. Instead of calling this point value, I'm just going to call this like money amount, I guess. And then over here, this will be money amount times It's the end of the day, you guys. I'm sorry. I'm not coming up with like good explanations for things. But at least you get a video. Okay. So the different money amounts we can get are, let's do this in cents because that'll be easier than dealing with decimal places. So a penny is 1 cent, nickels are 5 cents, dimes are 10, and quarters are 25. And now what is the probability of each of those things? Okay, so how many coins do we actually have in the bag? We've got 20, 10, 10, and 5. I think that's 45 coins. Is that right? So these are all going to be out of 45. And then how many of each do we have? We have 20 pennies, 10 dimes, 5 quarters, or sorry, 10 dimes, and 5 quarters. Okay. I think I could simplify these, but, well, maybe since I'm going to be multiplying them together, yeah, maybe I'll take a 5 out of the numerator and the denominator on each one. You could even just convert this to a decimal, but I'll just divide top and bottom both by 5. So this will be 4 over 9. This will be 2 over 9. This will be 2 over 9. And this will be 1 over 9. Let me make sure those still add up to 1. 4 plus 2 plus 2 plus 1. Yeah, okay. All right, so now I'm going to take these money amounts in cents, and I'm going to multiply them by each numerator here, and then the answer is still going to be over 9. Okay, so 1 times 4 over 9, 5 times 2 over 9, 10 times 2 over 9, 25 times 1 over 9. And now we're going to add these up. Let's see, 45, 55, 59. Okay, I didn't use a calculator, but hopefully this is correct. Maybe we should actually see what this is to see if it makes sense as an answer. You can always tell if you're way off because your expected value is an average. It's the average amount of money you should get. So it needs to be between the minimum and the maximum. It needs to be between these values over here. Let's see, 59 over 9. Yeah, I'm getting 6.5, so that's like between the nickel and the dime. So that seems fine. All right. That is it for this type of question. And if you have any concerns about this, you can send me an email or come to office hours.